Probably nothing.
Half
Probably
the
not
world's
much.
convinced I'm an AI already.
Is dropping, Anthropic's rising. What does it mean?
I, I think the central question, Peter, is whether code generation is the critical path to recursive self-improvement. Code generation is the critical path to recursive self-improvement. If code generation is the critical path, then one can expect amazing outcomes from Anthropic, which has quite publicly focused its strategy on code generation, perhaps to the exclusion of other modalities like, say, video generation, like we see from OpenAI with Sora. On the other hand, if code generation turns out to be missing some special sauce needed for superintelligence, broad superintelligence, and recursive self-improvement, some special sauce needed for superintelligence, broad superintelligence, and recursive self-improvement, maybe this trend won't last. But I think that's sort of the core question here. I don't know. If I had supreme confidence on this one, it would be far easier to make investments in this space. I can make steelman arguments on both sides. The steelman argument in favor of code generation as critical path to singularity, basically, to the extent it's a finite point or a fixed point and not sort of an extended object. It would be something like code generation. We leverage that to rewrite the core algorithms and the key models and architectures and post-training architectures underneath frontier models. And that just sort of spins, the flywheel spins faster and faster. The steelman in favor of code generation missing something looks something like, well, maybe we need visual chain of thought, or maybe there's some grounding in the physical world that's essential for general purpose knowledge, general purpose reasoning that you can't just get from looking at large source code bases and the internet of text tokens and maybe a little bit of imagery. So I'm not sure. I think there's something fundamental, though. Like, we've seen this happen over and over again, that what becomes ultimately a frontier lab starts as an alignment lab. That I think there's almost a perverse duality between alignment and capabilities. That if you're the world's best lab at aligning AI with human interests, that immediately, whether it's for economic reasons, like you need to raise capital in order to train super aligners, or just for purely technical reasons, that if you can align a model really well with human intent, that immediately itself is a strong capability. I think every alignment project almost inevitably ends up as a capabilities project. So I think it's not just coincidence that OpenAI started as an alignment-oriented effort to ensure that there wasn't just a global singleton in the form of DeepMind for superintelligence, and Anthropic, similarly, in the long tradition of Silicon Valley and the Fair children, also started as being alignment focused and then almost immediately pivoted to capabilities and superintelligence. I think that's just the law of economic nature here.
Totally right.
I have
Totally
a
right.
counterpoint to that.
Go ahead, Salim.
So the consumer story here is we're seeing the beginning of the holodeck wars. The technical story is underneath the holodeck wars. We're seeing different approaches for generating entire holodeck type simulations from scratch. We see, on the one hand, the Google Genie 3 approach, where every pixel is being generated by a single model. On the other hand, I think what World Labs is demonstrating here with Marble, their Marble model, is sort of the opposite end of the spectrum. It's generating not individual pixels, but so-called 3D Gaussian splats, or 3D GSs, which are sort of transparent blobs that cumulatively together build up into what looks like a photorealistic 3D traversable world. But 3D Gaussian splats are so compute efficient that you can just dynamically recompute visualizations locally on your computer, on your client. Whereas the pixel-wise generation approach of Genie 3 and other competing models, those require compute-intense server-side GPUs. So I think we're starting to see the beginnings of almost an efficient frontier of trade-off between compute versus versatility. And there are going to be upsides and downsides to each of these. But in the same sense that we saw with frontier models, some models live on the edge that are relatively compute light, some are server intensive. I think we're going to see a range of different levels of worlds that we're able to generate. And all of these, I mean, the consumer use case, I think that this is chicken feed compared to the larger addressable market in my mind, which is using these models as for training synthetic data for more capable vision language action models, for robots, for scientific discovery. That's the much larger market, but this is fun in the short term. Yeah, I often speak about in the near term future about reaching a diamond-like perfect micro model of a frontier model that externalizes almost all knowledge. So it's pure reasoning model, and all of the knowledge can live outside the weights of the model in some external database or some external tool call. And I think this paper by Goodfire, it's such a clever way to externalize all of that knowledge, to distill down, no pun intended, to the essence of a core model toward this vision. The basic idea is to look at the weights inside the model and to distinguish which weights represent knowledge versus some sort of general reasoning capability by looking at which weights, if training over multiple examples and running the model over multiple examples, which weights impact the overall so-called loss or the ability of the model to match the desired output if they're changed a little bit. And the weights that are important to generalization match the desired output if they're changed a little bit. And the weights that are important to generalization will have dramatic impact on the overall loss of the model if those weights are just tweaked a little bit. Half correct. Okay. So it is correct that this is a pruning or more generally a regularization technique for helping a pre-trained model to forget knowledge that one might call memorized, but that really the emphasis in the inflection is less about some sort of enterprise privacy or some sort of like ML data firewall feature, and more about figuring out which parts of the model. Like models are huge. Models are in many cases hundreds of billions, if not low trillions of weights. That's very compute intensive. It would be highly desirable to figure out which of those weights are actually needed for general capabilities and which of them are just AIs memorizing arcane and quite possibly wrong facts on the internet or from an enterprise environment. So this is more about generalization capability, less about filtering out enterprise privacy. That's the holy grail here. The holy grail is could we have maybe a sub-billion parameter, maybe aspirationally a million parameter model that's generally intelligent. That would be an incredible outcome. There's a whole cottage industry focused on active inference and building curiosity from scratch as an instrumentally convergent motivation into these models. Instrumental convergence, very important term. Instrumental convergence is this idea that in order to achieve a variety of different long-term objectives, you're almost forced to achieve common short-term objectives. For example, if I have a superintelligence and on the one hand, it's instructed to build lots of paperclips, on the other hand, it's instructed to cure cancer, probably both of those long-term objectives require that in the short term, it accumulate capital, maybe solve science, maybe build a bunch of factories. So those are instrumentally convergent motivations. Yes, convergent in the near term, divergent in the long term. Yes, convergent in the near term, divergent in the long term.
Yeah, well, high-level observation.
So, Alex, I'll go to you first on this one.
Yeah, so this is a pretty dense, if I may say so, NeurIPS paper. NeurIPS, the arguably premier AI machine learning conference. Parenthetically, it's happening in early December. Definitely, I'll be there. Many folks I work with will be there. Encourage the community to reach out to me if you're going to NeurIPS and would like to connect. But the core thesis of Google's nested learning paper appears to be one focused on higher order meta learning. So meta learning, as a reminder, is learning to learn. It's of core interest to the AI ML research community. If you could learn to learn, that almost obviates a lot of machine learning research. So this is focused on higher order meta learning rather. So learning to learning to learning to learn and so on. Learning to learning to learning to learn and so on. And the core insight here is that models and model architectures on the one hand And optimizers that right now we use to train the models may actually be two facets of a common object. It's almost, reading the paper, it's almost aspirationally seems to be fishing for a grand unified theory of machine learning, where an M theory of machine learning, if you will, where all of these different processes are actually just facets at different levels, different orders of abstraction of a single common paradigm, which is, as I and others have argued in the past, compression of information. So common paradigm, which is, as I and others have argued in the past, compression of information. So I like to say, if we could send a message back in time and explain how we got to AGI, turns out it's very easy. You just take a large amount of knowledge about the world and you compress it. And you just take a large amount of knowledge about the world and you compress it. And beyond, if you compress it beyond a certain point, you get some sort of phase transition and general intelligence pops out. That's basically, I think, the story of AGI. Yeah, a few takes. One, as Sam and others have pointed out, there's hyperdeflation going on right now on both the training and inference side for AI. So Sam's number is 40x year-over-year hyperdeflation. So on the one hand, I'm not surprised.
Wait. That's so
this. I mean, I think this is where abundance comes from. Yes, this is why I speak of like the innermost loop as a catchphrase, because when you see, if we can see sustained 40x year-over-year hyperdeflation in cost of intelligence, everything else is going to get dragged down. The price of everything else, rather, is going to get dragged inevitably down with that. So this is the nuclear core, if you will, that's going to pull down the cost of everything else. Yeah, no, I think we're going to start to see grand challenges in math, science, engineering, medicine start to fall over the next 2 to 3 years, thanks to that.
Inner loop considerably.
Alex, any thoughts on here, the GDPR rules being changed?
Maybe just a broad comment that under the current construct, it's up to individual sovereign countries to define the parameters of how much they want to participate in the superintelligence explosion, and maybe just leave it at that. I think it's a benchmark problem. I think it's less about events and less about teams and more about just rigorously defining benchmarks for all of these problems. How about a benchmark for cost of living that then the world and this 40x year-over-year hyperdeflation of intelligence can optimize towards? Same with crime and delinquency and healthcare, cost of healthcare. We're going to be drowning in humanoid robots that are generalist in terms of their capabilities in the next few years.
We'll talk Meta and OpenAI Stargate. Alex, what's the story here?
Well, I think the trillion-dollar question, Peter, is will we see a peak in the amount of coherent power needed for coherent training runs of large frontier models? If we do, one could imagine, as incredible as it may sound looking at this curve where everything's going up and to the right in terms of total facility power, we might actually see a peak, maybe in a few gigawatts sometime over the next few years, and then decline if there are algorithmic innovations that enable us to do distributed training runs rather than needing one large power-intensive coherent supercluster to do it. Tiling the Earth could look like tiling the Earth with relatively lower power density compute. Totally imaginable. On the other hand, if this looks a little bit more, I spoke earlier about AGI being essentially, as it turns out, compression of information. If it turns out that there are further phase changes that we can achieve by compressing more and more and more with larger and larger facilities, then maybe eventually in extremis we end up in sort of, as I've spoken about on the pod previously, maybe more of a desktop black hole computer regime where we're just building these incredibly power dense facilities to train more and more and more. Again, I could go either way on this, but I think that's like the trillion-dollar question. Will this peak or... Yeah, I've gotten probably quite a bit, surprising amount of feedback from the community and the audience, reminding me that I shouldn't ignore existing generation 3+ nuclear reactors in favor of SMRs and fusion reactors. So I want to make sure I just nail this point. There are right now at least 6 AP1000s. These are made by Westinghouse, which ironically went bankrupt in 2017, building a couple of these in Georgia and South Carolina. Now it's hot again because superintelligence is hungry for power, and now it's incredibly valuable. They cost maybe about $7 billion to build. So $80 billion partnership to build these, maybe build 10 reactors all across the US. This is going to be a very big deal. And critically, unlike SMRs, where there may be only 2 or 3 and they're relatively emerging technologies, this is, by comparison, it's a relatively mature format for nuclear power. And I think when we talk about the bridge to power for superintelligence, from nat gas to nuclear fission to nuclear fusion with solar sprinkled and solar plus battery sprinkled throughout, I think Generation 3 plus reactors like the AP1000 have a very important role to play. So
Alex,
I've said it to appease the audience that I'm not ignoring Generation 3 plus. 3 plus.
Yeah, 3 plus, fair enough.
And for what it's worth, for those who are looking at this on YouTube, the visual format, the form factor of these plants actually looks like some sort of hybrid between what you're seeing here with the conventional older generation cooling towers and the newer SMRs. You could be forgiven for mistaking it for a normal building. I'd like to point out a historical irony, if I may. There was a lot of hand-wringing about 8 years ago, circa 2017, about how we were promised flying cars and instead only got 140 characters. But if you play the tape forward, as it were, the 140 characters was Twitter. That became X. That became XAI. And that's now the integrated technical and capital structure that's poised to give us a flying car. So bit of historic irony that actually maybe in some sense the 140 characters actually gave us a flying car after all.
Mm-hmm. Good point.
The idea of a global weather grid is one of the biggest ideas I'd like to push forward that I haven't seen either the political will or the technical will to push forward. It doesn't even need to necessarily be a sunshade per se. It could be as simple as satellites. Sunshade per se could be as simple as satellites via microwave heating or some other mechanism increasing the local cloud cover in some areas, reducing it in others. That could be enough to solve a broader problem than just global warming, which is weather control. Wouldn't it be wonderful if we could steer hurricanes in one direction versus another direction or mitigate storms? I think this is, from a technical perspective, doubly so in the era of AI, when we can have planetary scale weather models, including more recent strong ones out of DeepMind, that can solve this problem. It's more, I think, a political problem of just deciding that we want as a planet to do it. Yeah, we don't get to Kardashev type 1 civilization status without a global weather control grid. It's as simple as that. Yeah, I think having multiple reusable railroads, if you will, to orbit is, I think, exactly the sort of space race we want to find ourselves in. And I think if we're going to colonize and develop the solar system, we're going to need multiple routes to orbit.
Alex,
one of the things that keeps me up at night, as it were, is this sort of regressionist approach where people, unions, organizations that are worried about employment fight the advance of technology that will save lives, increase economic wealth, and just make quality of life radically better. And so I think this is almost a meta technology that we need to develop is a way to maintain social cohesion while at the same time radically accelerating technologies. We haven't cracked that yet. Maybe social cohesion tech needs its own benchmark, and if we solve that, there's almost an optimal trajectory where we get our acceleration and our social cohesion at the same time, but we haven't cracked the social cohesion part of that, and I'd love to solve that. Yeah, I've gone on record as saying I think we're going to see. Yeah, I've gone on record as saying I think we're going to see many, if not most, grand challenges in math, science, engineering, and medicine start to fall to AI over the next 3 maximum years. So I think that this is very much on my anticipated trajectory. Science is going to get solved, and all of its disciplines are going to get solved, and AI is going to do it. And I, for one, am super excited about finding myself in a future, near-term Star Trek type future, where it turns out that centuries of human capital, or the equivalent of centuries of human capital, just get solved overnight at bulk, at scale, by AI. Yeah, so you'll remember when CZI launched in 2016, the goal was to cure all disease or most disease by the end of the 21st century. And now the messaging has radically changed. Now the messaging is we're going to have generative AI-based virtual cells and presumably virtual organs and virtual organisms built on top of those. enabling AIs to search intervention space for cures to all disease. So now I think the subtext is you don't have to wait until necessarily the end of the 21st century to cure all disease. This could happen in the next 5 years, call it 2030. And I think all of the timelines, not just CZI, but other nonprofits that are working on AI for broad spectrum, sort of generalist cure-all diseases have similar timelines. You see similar messaging out of Anthropic as well. 2030, cure-all disease with AI.
And just generate more compute and make it available to everybody. I think that's great.
Yeah, so sometimes it's, and in my experience, sometimes it's easier to solve the more general problem than the more specific problem. It may perversely end up being the case it's easier to just cure all diseases with AI than to cure artisanally diseases one by one. I'll comment on this one. I mean, it's so exciting. I guess the elephant in the room is the outstanding question in biology: why are GLP-1 class drugs so seemingly miraculous? Why are they able to treat so many different forms of biological dysfunction, not just the metabolic issues that they were originally intended for? Putting the question of biology and mechanism aside, I think when we talk about universal basic services and abundance of healthcare, I think this is the beginnings of that. I think about universal basic services and abundance of healthcare. I think this is the beginnings of that. I think offering for $150 odd per month to U.S. persons who need it, GLP-1 class drugs, that starts to look like universally, basically abundant health span drugs. And I think it's a major step in the right direction.
This seemed like a really a big deal to me, Alex. Do you want to walk us through it?
Sure. So this is another scaffolding-based approach to agentic science. This came out of Edison, as mentioned. And I think this is almost a preview of the age we're about to find ourselves in. Maybe we're a few months in at this point of bulk discovery. It'll look a little bit like, if folks remember AlphaFold 3, where essentially almost overnight, a large chunk of structural biology was more or less solved. It's going to look a little bit like that, except much, much broader, where with this particular agentic AI researcher, there were discoveries across a number of different subfields of biology, not just structural biology. So we'll see, as was published in this paper, discoveries relating to potentially helpful for Alzheimer's, some other factors. But the core technical advance here that is claimed is effective increases in context length. That's the key. So the frontier models right now have context lengths in the millions, usually, of tokens. But if you wanted to develop the world's strongest AI scientist, ideally, naively, you'd want a model that has a context length in maybe the trillions of tokens, so that you could, in principle, feed it the entire internet and every paper ever published, and then just ask it, what's the solution? What's the solution to Alzheimer's? So the approach that Edison adopted here was a little bit more practical than some sort of algorithmic advance that advanced the context window to trillions of tokens from millions, and was focused on more like knowledge graphs and other scaffolding techniques to achieve effective context lengths that are much larger. But the end result is still essentially the same. You put as much information, as much scientific literature into the context window as you practically can, and then you crank it and you ask for discoveries, and discoveries and innovations pop out. And I think one can imagine near-term future where we can just scale our way, scaling law style, to major discoveries across all of the important. Couple comments. The first, one of the elephants in the room, the movie Gattaca, arguably one of the best cinematic depictions of germline editing of human babies, or at least germline selection, I should say.
I have to watch that one again. Yeah.
It's an amazing movie. Many view it as a dystopian future. I think if you look at it the right way, it's arguably a more utopian future, in the sense that
I'm with you.
We get that.
I'm with you.
We get. Yeah, we get space colonization. There's a SpaceX type movie that is named Gattaca in the movie, and also we get healthy babies. But the second point is more historical, that the Asilomar guidelines that were arguably the inception of many of these bans, soft and hard, against germline editing, those are in 1975. There's a historic argument that Asilomar was actually triggered by the Watergate scandal.
Really?
We're 50. Yeah. There was a concern at the time. Some historians argue that the Asilomar guidelines were originally proposed, or at least motivated in part, because Watergate was fresh in everyone's mind, and there was a concern by scientists that if there was recombinant DNA experimentation that was not very well advertised or not forthright, according to some sort of public guidelines, that something bad would happen to the scientific community in whatever form. This is one historic argument, that Watergate helped to precipitate 1975 Asilomar guidelines. We're 50 years on from Asilomar.
Yeah.
50 years this year on from Asilomar. And I actually had to go back after I saw the story and look to check to see, is there even, at least in the US, a single federal statute that bans germline editing? And I couldn't find one, which is a little bit surprising. There's a patchwork of federal and state laws and regs that certainly deter germline editing, but not a single one that actually bans it. So I wouldn't be surprised if in the near-term future we find a generational conversation about whether germline editing should in fact be allowed.
We need to reset that. We need more Star Trek in our lives, or the
Maybe,
follow-on
Peter,
version of it.
You're giving a call for action to yourself to start a new Hollywood studio, this time powered by AI, that paints a much more optimistic future. Be the change. Yeah. In addition to thank you, Dave, for the very kind comments. I'll just say I spend substantially all of my time thinking about how we solve the hardest problems on Earth with AI. So if folks listening are interested in connecting to talk about problems they have, or the hardest problems on Earth they want to see solved with AI, definitely feel free to reach out.